Hi everyone. So on behalf of Stark Industries, uh, which is backed up by a famous Indian investor, Vijay Mallya, I would like to introduce my team. I am Ashwin. We have Arihant, Anurag and Aswath in our team. So if you could come closer, I will explain you the high cost design. So as you can see, we have different regional sites: Lafayette, Denver, Broomfield, Louisville, Longmont, and Superior as the different LAN networks. So in the LAN networks, we have segregated the VoIP and the video traffic using different VLANs on switches. Also, for video surveillance, we have provided these servers at the LAN sites. As you can see, server 1, server 6, server 4, so that all the video surveillance traffic will be stored at the servers during the daytime where there is heavy traffic on the main links, but during night time where the load is less on the major links, the backup traffic will go to the headquarters. So the main idea of our implementation is decentralization of the headquarter operations to a data center implementation. As you can see here, we have the core switches, distribution switches. So this is the Boulder headquarter, and its entire operation happens in this data center model, as you can see here. So now coming back to the redundancy part, all the LAN networks have a optical fiber connection to the headquarters, to the data center model. As you can see, Denver site has a OFC link to DS1. Louisville has a OFC link to DS3. So these are very high bandwidth links, which will be used as the primary path by the LANs to connect to the data center model. This is our headquarter here, and we have two firewalls which monitor the traffic going out and coming from the internet. So as a redundant method, we have built up VPN tunnels at the provider edge routers to the ISP networks, as you can see here. So suppose if the Denver to DS1 link goes down, we have a VPN tunnel connecting to the ISP as a backup method, but still the ISP network has to go through the firewall so that the traffic can be monitored. So, and as you can see, we have two SDN controllers here. So this is the general overview of our high cost design. Now I will just explain you the cost analysis of the high cost design. So as you can see, the network equipment, so the router switches which we have used cost around 21,000 approximately. The storage servers for the video surveillance storage cost around 16,500 approximately, and the firewalls cost around 9,500. So the total static storage cost is 47,000 approximately, which will not change for a long period of time. But the internet connection, as Professor Perigo had mentioned in the class, this is the major cost which the network provider has to plan out. So for us, it's coming out to be $650 per month, and we have such 9 internet connections, so it's coming to be 5850. And this is the optical fiber provided by Zayo. It's 2600 per month into 7 such connections. So roughly the dynamic cost is coming to 24,050 per month.
Moving on to the low cost design, what we did is we basically removed the major internet cost that is through the optical fiber interconnects, and we made it through ISPs. So we gave an ISP, so it's going to be a full mesh VPN connectivity to the central site, and we also removed all the redundant links. So if you could focus on the topology, I'll explain more. So the difference between the high cost and the low cost design is basically on the interconnects and the redundant links. We have still retained our core and our distribution network, and the major addition that we are doing is the entire network is going to be an SDN based network. So we are going to be preferring low cost SDN switches and possibly open sourced controllers for low costs, for low sites which have like 25 or less than 25 employees. For sites having more than that, we have a redundant ISP links and as you see, all these ISP links will have a full mesh connectivity with each other, and even if the link goes down, that's going to be taken care. Over here, it's the core network and the distribution network are a SDN network, and we have this high cost server which is also acting as a backup controller. So in our entire design, our servers are now acting as backup controllers, and for the remote sites, the servers are controllers as well. We believe that the servers can handle the network traffic, as it is okay for the remote sites, and since we have multiple controllers, I think the traffic should be good enough for storage as well as for network control. For SDN controllers to function as well. And moving on to the cost, we are really saving a lot exactly in the network equipment because of SDN equipment. So basically, with a 40% savings, we have calculated the cost to be $12,600. We have no firewalls, and it's completely moved to the SDN network. So as SDN can do firewalls, we have complete firewalls for each and every site done by SDNs. The storage servers are retained at the same price, and we can see that we are achieving almost 55% savings on the static cost. For the ISP cost, it's going to be the same cost. We're going to be taking the level 3's connection, but we're going to be having backup ISPs as well. So it's going to be twice the cost of the original ISP, and it's going to again have a 55% cost savings.
Now we'll move on to the IP addressing plan first. So as you can see here, we'll be using our IPv6 networks for our internal LAN connections, and the headquarters, the router at the headquarters will perform the NAT-PT operations so that the IPv6 network could connect to the internet via IPv4 backbone. And moving ahead with the timeline that we have decided to go about the network design, we have divided it into 4 blocks of 15 days each. The first 15 days would be heavily invested in designing the network, and also peering with the ISPs, as each of our sites has ISP connections for our VPN connections. So we'll require peering with the ISP, so we'll invest these 15 days to get optimum ISP connections. And moving to the next 15 days, we'll be configuring our local area networks in the regional sites with proper NAT configurations, and proper subnetting for optimal routing will also be done during this period. And moving ahead to the next 15 days, as this is the most important part where we'll be designing our data center core, as all the sites will be connecting to this. We'll ensure that all the distribution layer switches are connected to the core layer switches, and also the distribution layer switches are connected to the provider routers at each of the sites. And moving to the last 15 days, here will be configuration for the end users and the QoS capabilities. We'll be configuring different VLANs for our VoIP traffics and our video surveillance traffic as well. And we'll be configuring our access lists and distribution list as well. So that's about the timeline, how we'll be going forward with our network design, and that's it. Thank you.
Thank you for listening to our presentation, and on behalf of my team, I would like to thank our angel investor, Dr. Vijay Mallya, for investing in our network. Thank you.